Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is integration by parts. Let's start off with this video with a couple of integrals that we should already be able to do to get us started. First, let us take a look at the following example. Let me post that question on the board. Integration of e raised to x is very simple. This is again e raised to x plus c. So that was simple enough. Am I right? Okay, let me show you one more example. Now let's take a look at this example. To do this integral, we will use the following substitution. You have to assume this as u equal to x square. If you find du, you will get 2x dx. Am I right? If you just rewrite this, you will get du over 2 for x dx. So you can use all these to replace for substitution. You can write e raised to u and x dx can be replaced by du over 2. Am I right? So by substitution, this question integral x times e raised to x square dx can be rewritten as integral 1 over 2 e raised to u du. Now let us find the integration easily. Take the constant out. 1 over 2 can be taken out of the integral, and then after finding the integration for this one, e raised to u du, you will just get e raised to u plus c. So again, simple enough to do provided you remember how to do substitutions. By the way, make sure that you can do these kinds of substitutions quickly and easily. From this point on, we are going to be doing these kinds of substitutions in our head. If you have to stop and write these out with every problem, you will find that it will take you significantly longer to do this problem. So, we need a formula type for this one. Now, let's look at the integral that we really wanted to do. Do you see this question? If we just had an x by itself or e raised to 6x by itself, we could do the integral easily enough. Likewise, if the integrand was x times e raised to 6x square, we could do the integral with a substitution. Unfortunately, however, neither of these are options. So, at this point, we don't have the knowledge to do this integral. To do this integral, we will need to use integration by parts. Do you all agree with me? So, let's derive the integration by parts formula. We will start with the product rule. This is the product rule. Now integrate both sides of this. By integrating both the sides of this equation, this formula we will get. Now let's see the left side. The left side is easy enough to integrate. We know that integrating a derivative just undoes the derivative. So we will split up the right side of the integral. By splitting up, you will get integration f dash of g dx plus integration f g dash of dx. Hope you are clear with this step. Note that technically we should have had a constant of integration show up on the left side after doing the integration. We can drop this at this point since other constants of integration will be showing up down the road and they would just end up absorbing this one. Finally, let's rewrite this formula as follows, and we arrive at the integration by parts formula right now. This is not the easiest formula to use, however. So let's do a couple of substitution. I'm going to assume u and v. Let u equal to f of x and v equal to g of x. Let's also find du and dv here. Du will be f dash of x dx and dv would be g dash of x dx. Both of these are just the standard calculus substitutions that hopefully you are used to do by now. Let's not get excited by the fact that we are going to use two substitutions here. They will work the same way. Using these substitutions gives us the formula that most people think of as the integration by parts formula. Let me give you the formula which I posted at the starting of the video. Here is the formula. To use this formula, we need to identify u and dv. And also we have to compute du and v, and then we can use the formula. Note as well that computing v is very easy. All we need to do is integrate dv. One of the more complicated things about using this formula is you need to be able to correctly identify both the u and dv. It won't always be clear what the correct choices are, and we will on occasion make the wrong choices. So this is not something to worry about. If we make the wrong choice, we can always go back and try a different set of choices. This does lead to the obvious question of how do we know if we made the correct choice for u and dv? The answer is actually pretty simple. We made the correct choices for u and dv if, after using the integration by parts formula, the new integral, the one on the right side of the formula, is one we actually integrate. So here is an order for u. You can choose u in this order. The order name is LIATE. L denotes the logs, I means inverse, A denotes algebraic, T denotes the trigonometry, and E is nothing but exponential. Hope you are clear so far? So let's take a look at the integral above that we mentioned we wanted to do. Let me take an example and explain you step by step. I'm going to take the same question that I mentioned. So let's get back to this problem. Evaluate this following integral. So on some level, the problem here is the x, that is in front of the exponential. If that was not there, we could do the integral. Notice as well that in doing integration by parts, anything that we choose for u will be differentiated. So it seems that choosing u equal to x will be a good choice, since upon differentiating the x will drop out. Now that we have chosen u, we know that dv will be everything else that remains. So here are the choices for u and dv as well as du and v. U would be equal to x. So obviously du would be dx. Let dv be e raised to 6x dx, the leftovers, the remaining. So v would be, which is nothing but 1 over 6 e raised to 6x. Now we are going to rewrite this as the formula. The integral is then x times e raised to 6x dx would be equal to x over 6 e raised to 6x. I'll write it. We are just writing according to the formula. All you have to do is identify u and find du, and then write the leftovers, the remaining, as dv and find v, and write the formula. Now we are going to find the integral and write the final answer. So this is going to be the same. If you take the constant out and write this e raised to 6x, that would be e raised to 6x over x. So this would become negative 1 over 36 e raised to 6x. Please don't forget to mention the c. Once we have done the last integral in this problem, we will add in the constant of integration to get our final answer. Note as well that, as noted here, we know we had made a correct choice for u and dv, and when we got a new integral that we actually evaluate after applying the integration by parts formula. Hope you are clear with this example. So this is how we use the integral by parts formula. Next, let's take a look at integration by parts for definite integrals. The integration by parts formula for definite integrals would be, here is the formula for integration by parts definite integrals. Note that uv, this bar ba, is the first term, just the standard integral evaluation notation that you should be familiar with at this point. All we do is evaluate the term uv. In this case at b, then subtract off the evaluation of the term at a. At some level, we don't really need a formula here, because we know that when doing definite integrals, all we need to do is evaluate the indefinite integral and then do the evaluation. In fact, this is probably going to be slightly easier, as we don't need to track evaluating each term this way. So let's take a quick look at a definite integral using integration by parts. I'm going to take one example for the same question. I'm going to use some value for b and a. Here is the example. This is the same integral that we looked at in the first example. So we will use the same u and dv to get the answer. So I'm going to take the same thing. Only change is I'm going to mention a and b wherever necessary. We could just easily use the result from the first example to do the evaluation. First, you have to do for the top one and then the bottom. So I'll get evaluate for 2 and then subtract after evaluating for negative 1. I'm getting 11 over 36 e raised to 12 plus 7 over 36 e raised to negative 6. As noted above, we could just as easily use the result from the first example to do the evaluation. We know from the first example, this integration without the limits We just got plus c at the end. Using this, we can quickly proceed to the evaluate of the definite integral as follows. I'll show you on the board. This is the result we got in our first example. If I just use this numbers -1 and 2, I'll get, now you can evaluate for 2 and then subtract and evaluate for -1, and you'll be getting the same answer. I just wanted to show you that you'll be getting the same answer. So either method of evaluating definite integrals with integration by part are pretty simple. So which one you choose to use is pretty much up to you. Since we need to be able to do the indefinite integral in order to do the definite integral, and doing the definite integral amounts to nothing more than evaluating the indefinite integral at a couple of points. We will concentrate on doing indefinite integrals in the rest of the video. I'm going to divide this video into two. So in fact, throughout most of this video, this will be the case. We will be doing far more indefinite integrals than definite integrals. So, hope you're clear with all the details that we discussed in this video. In case if you get any query, kindly feel free to let me know. I shall be glad to answer all your query. See you in the next video. Have a great